Welcome back, Chemistry 30. This is the lab entitled Molecular Geometry. So it occurs in between MS 1.5 and 1.6. So we'll take a look at this. The objectives here are to write Lewis structures for molecules, recognize exceptions to the octet rule, draw accurate representations, and describe three-dimensional shapes using the VSEPR theory, or valence shell electron pair repulsion theory. So we'll be going to this site here in a bit, and the nice thing is that you can use your phone, whether it's iPhone, Samsung, Android of some kind, it works, so that'll be great. So you can read this introduction on your own. I'm just going to jump right to the two activities. So the first one's going to be involving drawing Lewis structures. The second one's going to be using the website and the simulation to figure everything out. So if we look over here, so let's draw these structures, just like the way we have been doing it. We'll maybe do this first one together. So ammonia, NH3, we can see that we have one N and three H's. And of course, nitrogen is in group 5 if you look on the periodic table. So that means it's going to have 5 valence electrons. Hydrogen is in group 1, so it's going to have 1 valence electron. So we'll have 5 plus 3, that equals 8 valence electrons. So if I was to draw this structure, of course, N would be the central atom because it occurs once. It also has a higher electronegativity. So 2, 4, 6 electrons, we need 2 more, so we say that it goes to the central atom because guess what? H is good. So we look at formal charges now. Hydrogen's in group 1. Nitrogen is in group 5, so we take a look at the number of electrons being involved here. This H has 1 electron involved, so that's going to give us 0. Same thing with this H, and same thing with this H. So the H's are good. Nitrogen, how many electrons does it have in being involved with this structure? 1, 2, 3, 4, 5, so it's good. So this structure looks good. Now, does it violate the octet rule? And more specifically, does the central atom violate the octet rule? So if we take a look here, the nitrogen is 1, 2, so we count the whole things here, right? We count everything. So this 2, 4, 6, 8. So the nitrogen thinks that these shared ones belong to it. There's a total of 8. So there's no violation of electron rule, or of octet rule, sorry. Electron domains. If I look at what domains are, okay, maybe just write this at the top of the page. Those are areas around the central atom where electrons are found. So if I look around the central atom, where can I find electrons? So on this nitrogen, I can find electrons above, electrons to the right, electrons below, and electrons to the left. So there are 4 electron domains. Similar to how we did Lewis structures, we have up, down, left, right. Could have possibly more areas too. And then out of those 4 domains, how many are bonding? So let's see here. Bonding, bonding, bonding. These 2 electrons above here are not bonding. They are non-bonding. So 3 of them are bonding. So that's going to be important when we move on and talk about non-bonding versus bonding domains. Okay? So you got some free marks there if you copy that out. That's what you need to do for activity 1. And keep on trucking here. If we look at activity 2, we're going to have to open up this simulation here to have this. So if we go to Google, the best way to get there is just to simply type PhET. And we want Sims. And we're in chemistry class, so of course we're going to click on chemistry, general chemistry. Scroll down until we get to molecule shapes. Not the basics, but just the one that says molecule shapes. Press play. Hopefully it should work. And yes, we just want models. So if we go here, a couple of things we're going to have to toggle on. electron geometry and molecule geometry, toggle that on. Also, we want to see bond angles. So what we can do is we can add attached atoms, move it around, get funky. We can also add lone pairs or non-bonding electrons. So notice it's kind of a bubble which represents where these electrons can be found. It takes up more space than a bonded one, and you can see the 2 electrons there. All right, so if you take a look back to here, when you have 2 electron domains, we'll assume that they're bonding ones. If I go back to there, 2 bonds, and no matter how I move this around, it goes back to 180. So 180. So that's how you do that. If we move on to the next page here, let's just pick a random one. How about this one right here? Let's look at 4 domains. 3 of them are bonding and 1 non-bond. So let's see here. 3 of them are bonding and 1 non-bond. There we go. That's the shape that we're going to get. So you can see the magical angle there, 109.5, no matter how I turn it. And what I'm looking for here is what's the electron domain geometry? Electron geometry can be found right here. Make sure it's toggled on, tetrahedral. So you'd type in tetrahedral right here. And looking at the molecular geometry, molecule geometry, trigonal, pyramidal. So that's what you would write over here. All right. So that's what you need to do for this lab, basically using that online simulation, which can be found on the PhET website. So run through that, and you should be good to go. All right, we'll see you again.